Hi, this is Srikanth, Assistant Professor of Triple Department. In this session, I am going to discuss some problems on DC generators. A 4-pole generator having wave-wound armature winding has 51 slots, each slot containing 20 conductors. What will be the voltage generated in the machine when driven at 1500 rpm, assuming the flux per pole to be 7 milliwebers. Here the given data is, it is wave wound armature winding. Wave wound is nothing but number of parallel paths are 2 and number of slots are given 51. Number of slots is equals to 51 and each slot contains 20 conductors, that is 20 conductors per slot. Now we need to calculate what is Eg when at a speed of 1500 rpm and flux is given as 7 milliwebers. 7 into 10 to the power of minus 3 webers. So here our generated voltage equation Eg for a DC machine is phi Zn by 60 into P by A. Here phi is the flux, Z is number of conductors, N is speed, P is number of poles and A is number of parallel paths. Here the number of poles is given as 4. And here the number of conductors directly it is not given, but the data corresponding to calculate the number of conductors is given, where Z is equals to number of slots into number of conductors per slot, that is 1020. So here phi is given directly and Z we have calculated 1020 and P is equals to 4, A is equals to 2 and N is equals to 1500 rpm. If we substitute these values into this equation, 7 into 10 to the power of minus 3 into 1020 into 1500 by 60 whole into 4 by 2, which is equals to 357 volts. The next problem is an 8-pole DC generator has 500 armature conductors and a useful flux of 0.05 webers per pole. What will be the EMF generated if it is lap connected and runs at 1200 rpm? What must be the speed at which it is to be driven produce the same EMF if it is wave wound? Here the data given, number of poles is equals to number of parallel paths, which is equals to 8 because it is lap connected system. In lap connected A is equals to P, number of parallel paths is equals to number of poles, and here the number of conductors is given as 500 armature conductors and useful flux is given as 0.05 webers per pole and lap connected and runs at 1200 rpm. What must be the speed at which it is to be driven to produce the same EMF? So for that, first let us calculate the EMF with lap wound. That is, EMF Eg is equals to phi Zn by 60 into P by A. Here which is equals to 0.05 into N, because here Z is constant, Z is 500 into N by 60, that is 1200 by 60, which is equals to 20, and into P by A, number of poles is equals to number of parallel paths, so which is equals to 1, which is equals to 500 volts. The EMF generated with the lap winding is 500 volts. Now we need to check that what must be the speed at which it has to be driven for the same EMF which we need to generate. That is, here the P is equals to 8, A is equals to 2, P by A is equals to 4. So the EMF generated is equals to 0.05 into 500 into N by 60 into 4. So here EMF E is equals to 500, N should be equals to, if we want EMF as 500, which is equals to 0.05 into 500 into N by 60 into 4. This 500 will get cancelled, and you will get 0.05 into 4. From this we will get N is equals to 300 RPM. The speed which we are getting is 300 RPM. Hence, with the wave winding, it must be driven at 300 RPM in order to generate 500. The next one is a DC shunt generator has an induced voltage on open circuit of 127 volts. When the machine is on load, the terminal voltage is 120 volts. Find the load current if the field circuit resistance is 15 ohms and the armature resistance is 0.02 ohms. Ignore armature reaction. Here, this is the DC shunt generator which we are considering, and here the data given is the terminal voltage is 127 volts, and we need to calculate when the machine on load, the terminal voltage is 120 volts, and we need to calculate the load current if the field circuit resistance is 15 ohms and the armature resistance is 0.02 ohms. Here let us consider the armature resistance which has 0.02 ohms. Now this is the generator circuit that is on no load. The machine runs at N1 RPM, where Eg is equals to 127. Eg is equals to Vt plus IARA. That is 127 plus Ia into Ra, that is 0.02. Here Ia value how we'll get is, here the RSH value is given as 15 ohms, okay, and armature resistance is given as 0.02. So here when it is on no load, when it is on no load, load current is 0. Here when the load current is 0, Ia is equals to ISH. Ia is equals to ISH. So that is equals to 127 by 15, which is equals to 8.47 amperes. So that is 127 plus 8.47 into 0.02, which is equals to 127.17 volts. Now when the machine is on load, the output voltage is 120 volts. When it is 120 volts, the field current is 8 amperes. That is ISH is equals to V by RSH. That is 120 by 15 which is equals to 8 amperes. Here the above figure shows the load generator running at a speed of N2, and from this figure the field current is equals to 8 amperes. Now if the speed is increased to N2 RPM, if the speed is increased to N2 RPM such that 8.47 into N1 is equals to 8 into N2. That is phi 1 N1 is equals to phi 2 N2, because EMF is directly proportional to flux into speed. So 8.47 into N1 plus equals to 8 into N2, or N2 is equals to 8.47 by 8 into N1, which is equals to 1.05875 N1. Thus the effect due to 5.875 percentage decrease in flux is compensated by 5.875 percentage increase in speed. If EG is assumed to be remain unaltered at 127.17 volts, IA is equals to 127.17 minus 120 by 0.02, which is equals to 358.5 amperes. Hence the load current is equals to whatever the IA value which we got minus IA minus ISH, that is 358.5 minus 8, which is equals to 350.5 amperes. The next problem is an 8-pole DC shunt generator with 778 wave connected armature conductors and running at 500 RPM supplies a load of 12.5 ohms resistance at a terminal voltage of 50 volts. The armature resistance is 0.24 ohms and field resistance is 250 ohms. Find the armature current, the induced EMF and flux per pole. Here the armature resistance is given as 0.24 ohms, which is the generator resistance, and this is the 250 ohms field resistance, and this is the 250 volts, and the load resistance is 12.5 ohms. Here the load current is equals to V by R, that is equals to 250 by 12.5, which is equals to 20 amperes. Shunt current is equals to V by RSH, which is equals to 250 by 250, which is 1 ampere. And armature current is equals to 20 plus 1, that is 21 amperes. The induced EMF is equals to 250 plus 21 into 0.24, which is equals to 255.04. Now the generated voltage EG is equals to 5 Zn by 60 into P by A, which is equals to EG value we got it as 255.04 equals to 5 into 778 into 500 by 60 into number of poles is 8 and the wave connected is 2. So the flux value phi is equals to 9.83 milliwebers. Now in a 120 volts compound generator, the resistance of armature, shunt and series windings are 0.06 ohms, 25 ohms and 0.04 ohms respectively. The load current is 100 amperes at 120 volts. Find the induced EMF and the armature current when the machine is connected as long shunt and as short shunt. How will the ampere turns of series field changed in long shunt if a diverter of 0.1 ohms to be connected in parallel with the series winding. Neglect brush contact drop and ignore armature reaction. Here this is the circuit which is given such that armature resistance is 0.06 ohms and series field resistance is 0.04 ohms and shunt field resistance is given as 25 ohms. And now we need to calculate the induced EMF and armature current with this data. And then when it is diverted with a small resistance with 0.1 ohm, what will be the ampere turns of the series field? We need to check. Here long shunt, that is our first figure. Here ISH is equals to directly 120 by 25. 120 by 25, which is equals to 4.8 amperes, where I is equals to 100 amperes, IA is equals to IL plus ISH, which is equals to 104.8 amperes. The voltage drop in series winding is 104.8 into 0.04, which is equals to 4.19 volts. And armature voltage drop is equals to 104.8 into 0.06, that is equals to 6.29 volts. When we are having the armature voltage drop, EG is equals to 120 plus 4.19, 120 plus 4.19 plus 6.29, which is equals to 130.5 volts. And the next one is, if I go with the short shunt, voltage drop in series winding 100 into 0.04, which is equals to 4 volts. Voltage drop in shunt winding is 120 plus 4, that is equals to 124 volts. Now the shunt current is equals to 124 by 25, which is equals to 5 approximately, which is 5 amperes. So IA is equals to 100 plus 5, which is 105 amperes. Now the armature voltage drop is equals to 105 into 0.06, which is equals to 6.3 volts. Now EG is equals to 120 plus 5 plus 4, which is equals to 129 volts. Now when a diverter of 0.1 ohm is connected in parallel with the series winding, the diagram which is here, this is the diagram which we are going to get, it is 0.1 ohm. As per current divider rule, current through series winding is 104 into 0.1 by 0.1 plus 0.04, which is equals to 74.86. So it means that the series field winding has decreased from an original value from 104.8 to 74.86. So here the ampere turns will be reduced by 74.86 minus 104.8 into 100 by 104.8, which is equals to 28.6 percentage reduction in the ampere turns, because the current is reduced because of the parallel connected diverter. The next one, a shunt generator supplies 95 amperes at a terminal voltage of 240 volts. The armature and shunt field resistances are 0.2 ohms and 60 ohms respectively. The iron and frictional losses are 2000 watts. Find the efficiency of DC generator. Also determine the value of load current at which the maximum efficiency occurs. Here the shunt field resistance is ISH is equals to V by RSH, which is equals to 240 by 60, which is 6 amperes, because shunt field is directly connected in parallel to the voltage in the DC shunt generator, where armature current IA is equals to IL plus ISH. Here the IL value is given as 95 amperes, 95 plus 6, which is equals to 101 amperes. The armature copper losses, which is equals to IA square RA, that is equals to 101 square into 0.2, that is equals to 2040.2 watts. The shunt field copper losses are equals to ISH square into RSH, that is equals to 6 square into 60, that is 2160 watts. The total copper losses is equals to 2040.2 plus 2160, that is 4200.2 watts. These are the total copper losses. Now the total stray losses are given equal to 2000 watts. So when the stray load losses are given as 2000 watts, total losses is equals to 2000 plus 4200.2, which is equals to 6200.2 watts. Now the output power is equals to V into IL, that is 240 into 95 is the load current, that is equals to 22,800 watts. Therefore the input power will be, input power PI is equals to P0 plus losses, which is equals to 22,800 plus 6,200, which is equals to 29,000.2 watts, where efficiency is equals to P0 by Pi, which is equals to 22,800 by 29,000.2 into 100, that is equals to 78.62 percentage. So here the efficiency we got it as 78.62 percentage with this particular load. Now the load current corresponding to the maximum efficiency, that is equals to constant losses is equals to shunt field copper losses plus stray load losses, that is equals to WC is equals to 2160 plus 2000, which is equals to 4160 watts, where IL is equals to square root of WC by RA, which is equals to square root of 4160 by 0.2, which is equals to 144.22 amperes. The next one is, in a 4-pole DC generator, the number of conductors are 600 and flux per pole is 0.02 webers and speed is 1600 rpm. Calculate generated EMF if the armature is connected in wave wound and lap wound. Here the given data is the number of poles is equals to 4, number of conductors are 600, flux per pole is 0.02 webers and speed is equals to 1600 rpm. For lap winding, the number of parallel paths is equals to number of poles, and the generated EMF EG is equals to 5 ZNP by 60 into A, which is equals to 0.02 into 600 into 1600 into 4 by 60 into 4, which is equals to 320 volts. Now for wave winding, the number of parallel paths is equals to 2, A is equals to 2. The generated EMF EG is equals to 5 Zn by 60 into P by A. which is equals to 0.02 into 600 into 1600 into 4 by 60 into 2, which is equals to 640 volts. Now, a 4-pole DC generator having wave-wound armature winding has 51 slots, each slot containing 20 conductors. Find the generated voltage in machine when the speed is 1500 rpm and the flux per pole is 60 milliwebers. The number of poles is 4, number of slots are 51, and number of conductors per slot is 20. So the total number of conductors is equals to 51 into 20, which is equals to 1020. And the speed at which it is going to drive is 1500 rpm. And the flux per pole is 60 milliwebers. That is 60 into 10 to the power of minus 3. Where the number of parallel paths A is equals to 2, the generated EMF Eg is equals to 5 Zn by 60 into P by A. That is equals to 60 into 10 to the power of minus 3 into 1020 into 1500 into 4 by 60 into 2, which is equals to 3060 volts. Okay, in this session I have discussed several problems on DC generators with efficiency and generated voltage problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.